pH. As we have learned before, we can distinguish between acids and bases safely using substances called indicators. These include natural indicators such as red cabbage and tea, as well as synthetic indicators such as litmus paper, as we see, or methyl orange. However, what if we were given two acidic or two basic solutions with the same concentration? Would we be able to distinguish which one is more acidic or more basic? This is where the pH scale comes in, which can help us answer these questions. pH is a measure of the acidity or alkalinity of a solution expressed on a numerical scale from 0 to 14. A pH value below 7 indicates an acidic solution, while the pH value above 7 indicates a basic solution, and the pH value of 7 indicates a neutral solution. The acidity of a solution increases as the pH value approaches 0, indicating an increase in the concentration of H3O+ ions in the solution. Conversely, the alkalinity of a solution increases as the pH value approaches 14, indicating an increase in the concentration of OH- ions in the solution. But how can we determine the pH value of a solution? Let's learn together. There are several methods for determining the pH value of a solution. The first method is using a universal indicator, which is a mixture of several indicators that come in a liquid or paper strip form. The indicator strip is dipped into the solution, and the color change of the indicator strip is observed. Then compared to the closest color match in the standard chart provided on the container. The pH value is also indicated next to the color on the chart to determine the approximate pH of the solution. The second method is using a specialized device called a pH meter, which provides more accurate measurements than a universal indicator. It's commonly used in laboratories and in many chemical industries. The third method is through the following mathematical expression, where the pH value equals the negative logarithm to the base 10 of the concentration of hydronium ions H3O+ in the solution. From this, we can derive the following equation, where the concentration of H3O+ equals 10 to the power of minus pH value. As a reminder, the logarithm of 1 is 0, while the logarithm of 10 to the base 10 is 1. And now let's solve some various exercises together. In the first example, it's required to calculate the pH value of a solution if the concentration of H3O plus ions is equal to 3 times 10 to the power of negative 4, where the logarithm of 3 is equal to 0.48. Using the pH expression, and distributing the negative logarithm gives the negative logarithm of 3 minus the logarithm of 10 to the power of negative 4. By lowering the exponent with the attention to the signs, then substituting the value of 3, and as we have mentioned, the logarithm of 10 to the base of 10 is equal to 1 as we see. By performing the calculation, we get that the pH value is equal to 3.52, which indicates that the solution is acidic. Another example is to calculate the pH value of a solution if the concentration of H3O plus ions is equal to 0.02. Note that the logarithm of 2 is equal to 0.3. Using the pH expression as we see, note that the given logarithm is for the number 2. So by shifting the decimal point 2 places to the right, we have a negative logarithm of 2 times 10 to the power of negative 2. Then, by distributing the negative logarithm, gives a negative logarithm of 2 minus the logarithm of 10 to the power of negative 2. By lowering the exponent with the attention to the signs, then we substitute the values, so the pH value is 1.7. This also indicates that this solution is acidic. Let's consider the pH values in the two previous examples, comparing them using the pH scale. We notice that the solution with a pH value of 1.7 is the stronger acid. As we can see, the lower the pH value, the stronger the acid, and indicating an increase in the concentration of hydronium ions in the solution. In the next example, it's required to calculate the concentration of H3O plus ions for a bottle of vinegar. Written on it, the pH value is 4. Note that in this question we are given a pH value and we need to find the concentration of H3O plus ions, where the concentration of H3O plus ions is equal to 10 to the power of negative pH. And by substituting the values, so the concentration of H3O plus ions is equal to 10 to the power of negative 4. In the following example, it's required to calculate the concentration of H3O plus ions of a solution with a pH value of 3.52, given that the logarithm of 3 is equal to 0.48. So, what is needed here is to find the concentration of H3O plus ions, and by substituting values. But note that the result is 10 to the power of negative 3.52. While we are given in the question, as we see, the value of 10 to the power of 0.48 is equal to 3. How can we solve that? Let's see. So we are going to substitute a value equal to 3.52, which is x minus 0.48. As we can see, x is equal to 4. So the concentration of H3O plus ions is equal to 10 to the power of negative 4 minus 0.48. So the result after substituting the values is 3 times 10 to the power of negative 4. Another example with the same idea as the previous question, and I would like you to share your answers with me in the comments. Big thanks for watching. At the end, don't forget to like, share, and subscribe to receive my new videos.